Listen carefully. So, this class we are going to discuss about Newland's law of octaves. Children, this Newland has introduced his own periodic table. Understood? So, last class we discussed about Dobereiner's periodic table. That is nothing but we call it as Dobereiner triads. Now, this class we are going to discuss another periodic table. Last class, sir introduced that Dobereiner's periodic table, all the merits and the demerits about Dobereiner's periodic table, isn't it? Now, this class we are going to discuss what do you mean by Newland's law of octaves. Children, listen carefully. According to this law, you should remember one thing. That is nothing but when elements are arranged according to the increasing order of their atomic mass, the properties of every eighth element starting from any element is repeated. Understood? So that means, for example, you can consider in this, you can consider lithium, isn't it? Below lithium, you have sodium, isn't it? So what are the properties which shown by lithium is similar to that of sodium, isn't it? Another example, you have fluorine, isn't it? Fluorine and chlorine, they are in the same table, isn't it? The property showed by fluorine is similar to that of chlorine. Understood? So based on this table, according to arranging them in octaves, we are able to understand which of them are showing similar property. So what Newland's observation is nothing but every eighth element, if we are starting from anywhere, every eighth element is showing the similar properties. Understood? So you consider like this: when elements are arranged according to the increasing order of atomic mass, the properties of every eighth element starting from any element are repetition of the properties of the starting element. Understood? Every eighth element will show the similar properties. Understood? Children, this is similar to the music, isn't it? Indian music. Sa, re, ga, ma, pa, da, ni. Understood? So similarly, what are the things starting from sa? So around the eighth element will show the similar properties. That's why I wrote like this. So children, listen carefully. We are talking about Newland's law of octaves. This law explains that every eighth element will show the similar properties of that stem. Understood? Any doubts in this? So how they arranged? Here also they considered atomic mass, isn't it? When they arrange elements according to that time, which are the available elements, they just consider that much only. So of the first element. Understood? So you can start from anything, any element, but they will show the similar properties of the first element. Every eighth element is nothing but the repetition of the starting element. Understood? Understood? Any doubts in that? For example, you can consider here lithium and sodium. They will show similar properties. Understood? Another one, you have fluorine and chlorine, isn't it? They also will show similar properties. So this is acceptable. Understood? Any doubts in this? Yes. So children, you please consider. So from this periodic table, we understood there are certain similarity. I'm just explaining that. According to this periodic table, we understood that the eighth element from lithium is nothing but sodium, isn't it? You can see that the eighth element from lithium is nothing but sodium itself. They show similarity in properties. Another example, you can consider fluorine. If you start from fluorine, its eighth element is nothing but chlorine, isn't it? The chlorine also is showing similarity in properties. Understood? Any doubts till this? Is it okay? Fine. Now, children, listen carefully. Now we are going to talk about what are the merits of Newland's classification. So what are the merits of Newland's classification? Children, listen carefully. This system of classification is good for light elements. Understood? For lighter elements whose mass are very less, atomic mass are very less, for those elements, this system is very well suitable. Understood? For example, lithium, sodium, and potassium. For these elements and all, we are able to relate their properties, isn't it? So lithium and sodium, you guys remember, isn't it? We are able to relate their properties. So This type of classification is useful for lighter elements. Understood? Now, how they are related, what property they are checking. In reality, they are relating based on the increasing order of their atomic masses, isn't it? So properties of elements are based on the atomic masses. We are telling every time, isn't it? Similar properties they are showing. What similar property they are showing? That is nothing but the properties related to their atomic masses. So we understood that there are two merits for Newlands classification. The first one is nothing but this system is well suitable for lighter elements such as lithium, sodium. Their properties we are easily able to relate. So what property they are showing? That is nothing but the properties of elements based on their atomic masses. Any doubts? Now, this Newland classification is rejected. We know that. We discarded that, isn't it? What is the reason behind this, discarding this type of classification? The reason is nothing but that time not that much elements were discovered, isn't it? Whatever elements were discovered, he introduced one law, isn't it? One periodic table, he just introduced. When more and more elements discovered, that such as heavier elements were discovered, this classification became a failure. Understood? So this classification does not work with heavier elements. That means lighter elements, this classification is perfect. But when we consider heavier elements, this classification is not at all working. Understood? That's the first reason which we discarding this type of classification. Now, when more and more elements were discovered, that means when the chemistry branch is advancing, that moment new elements were discovered. Understood? That time they are unable to fit in this Newlands octave. Understood? This first one is nothing but this classification did not work with heavier elements. If you consider lighter elements, yes, this classification is perfect. But for heavier elements, this classification is not useful. Second one is nothing but when more and more elements were discovered, there is no space for those elements to fit here. Understood? In Newlands octaves, we don't have enough space to fit them. Third one, iron. The character of iron, the properties of iron is similar to that of cobalt and nickel. But you remember in the periodic table, iron is kept in one place, cobalt and nickel is kept in another place. Understood? It is far from iron. Cobalt and nickel placed far from iron. Three of them are showing similar properties. Understood? So these are the three reasons which we discarded Newland's law of octaves. Any doubts? So this is for today, children. Have a nice day. Bye.